Yeah, I uh, this is the problem set, I believe, right? So the first question is simple. You will need to use list comprehension, okay, and you need to print a combination of these numbers, as in like when one is not the elements in x and elements in y are not equal, then you will need to print it. So 1 2 1 3 2 1 2 3 3 1 3 2, this way you have to print. Okay, this is also second problem is also simple. There is like product and prices. So what you need to do is you need to calculate the total, as in like product quantities into prices. So 13 into 1.2, then plus 5 into 6.5, plus 6 into 1.0, plus 10 into 4.8, plus 11 into 5.0, and then that will be your output 157.1. So again, you can do these things through for loop, while loop, and lot of complex logic. I don't want to do that. Apply the techniques which we have learned in previous classes, as in list comprehension, some of the functions. We have solved similar kind of problems. Try to do that way. Okay. Again, this is a simple problem. Take a sentence and output a dictionary with words as the key and number of characters in the word as a value. But all this while, again, we have been doing in a for loop and other things. Here, I want you to use dictionary comprehension. So for line question number 1, 2, 3, I want you guys to do that, solve these problems in at max or at 1 to 2 lines, not more than that. Aggregation, yeah. So there is a question here. Uh, there is a question. What is aggregation in question number 2? So aggregation is you need to multiply element by element and then add everything. So it will be something like this: 13 into 1.2 plus 5 into 6.5 plus 6 into 1.0. So I'm aggregating. So here I'm multiplying everything and then finally aggregate total, basically just add. Okay, there is one more thing. Sir, please explain question number 3 of today's assignment. What is question number? This is 1, this is 2, this is 3. So this is again the same problem we have seen. So what will happen? Hello?
Yes, sir.
Yeah. You guys are able to hear me, right?
Yes,
Yes.
sir.
Okay. So for question number 3, what you have to do is, so usually, like, let's say my name is Amit. This is a sentence. Okay. I will go word by word. So here, like, my will be a key for me. And then length or the number of characters in this word, which is 2. So value will be 2. Then again, name is a key and value is 4. Name is is a key and value is again 2. So this way I have to print something this way, but I want you to use simple dictionary comprehension for this, no complex logic. So here in like first to 3 problems, you will be awarded for writing a one-liner code or using like dictionary comprehension, list comprehension, or some functions of Python, which will I mean, not that conventional style of writing code, all I want to say. Okay, some maybe a little bit of Pythonic way of writing. So that is 1 to 3. Question number 4 is run the code below to generate. Yeah, so this is what we were discussing, found not found. Okay, that's all. There was one more problem, I guess. Yeah, and apart from this, there is one more problem: to use recursion, and solve for your Fibonacci number and your what was that?
Factorial.
Factorial. Okay, so some of you might be knowing already about this recursion and how recursion works. For those of you who don't, let me explain them for me. So I will take some 15-20 minutes to explain recursion, maybe Yes. Let's see. Okay. So, okay, give me a minute, huh? Let me explain recursion a little bit. So this is how recursion works. Okay. All this while you have been writing functions, right? You have been writing functions like def, your function name, right? And then you give your parameters, colon, and then your logic, and then you return something from this function, right? This is what we have been doing. And but there are some set of problems, there are some set of questions, okay, where you can break that problem into smaller chunks. I would say there will be some kind of symmetry, some kind of structure that you will be seeing. For example, this factorial problem, let's say. So this factorial problem, what is factorial of 4? This is 1 into 2 into 3 into 4, right? Now, if you observe this, 1 into 2 into 3 is what? This is 3 factorial multiplied by 4, correct? Right? So I
Yes.
can say n factorial equals to n minus 1 factorial multiplied by n. So this is my structure. So I am breaking my original problem into smaller problems of same nature or of same structure. Original problem is something, I'm breaking it to smaller problem of same nature, same structure. Is it not the same? This is also factorial problem. This is also factorial problem. Okay, there is one question from Aparna. Sir, question number 5 is 2 different problems, or we have to do in one? Those are, you can think of as 2 different problems. You will need to write 2 piece of code for that. Okay. So the original problem is n factorial. Now I'm breaking it to n minus 1 factorial, a smaller replica, or like so you can think like you are your bigger problem, you are converting it to a much simpler, much smaller problem, and there is a symmetry, there is a structure. Now n minus 1 factorial can be broken further as n minus 2 factorial multiplied by n minus 1 multiplied by n, correct? And so on, this will continue. Okay, guys, are you with me? You are able to understand this?
Yes, sir.
Yes,
Yeah.
sir.
Yes, sir.
Yes. Okay.
Yes, sir.
Okay, got it. Keep yourself on mute. Okay. Now, uh, so such kind of problems, there is a way of solving it. We call it as like, we have already seen these kind of problems. We have solved these problems using for loop or your some kind of looping struct. We have solved this problem, but same problem you can do with a style of programming called as recursion. Okay, but again, like, you can apply recursion only if this kind of behavior or this kind of structure you see within your problem. Otherwise you will not be able to do it. Okay, few things to highlight over here. All the recursion solution will look very nice, it will look very clean and very small, succinct, but performance wise they are not that great. Okay, but they, like, there are few other techniques which are like beyond the scope of this class. There is something called as dynamic programming and other things. Okay, these form the base of those dynamic programming solutions. Okay, so if you understand this recursion, it's a very good technique to know. And if you are coming from computer science background, and if you know this data structures and algorithm, like if you remember those things, so in that, like, all those three problems that you might be seeing, all those things, if you just try to implement using a loop, a for loop or something, it will look very messy. Your code will not look that clean. But you can have a very clean code with these recursion solution. But performance wise, they are not very great. So there are some limitations, like there is a stack memory which fills. So we will not go in that detail. Just try to understand that factorial problems require has some kind of structure, okay, and some, as in like, it is a combination of smaller problem of the same nature as the bigger problem that you had, multiplied by something, or maybe some other logical operation that you are doing. This kind of structure, if it is there, you can apply recursion. Okay, so how you apply recursion is, what in recursion, what is required, there is should always be a base case. Okay, there should always be a base case, as in like when your program should terminate. Okay, just like in for loop and while loop, we had some condition, right? Like I greater than this, I less than this. So at some point we want to break, we want to come out of the loop. Similarly, in recursion, we should have a base case. After that, your program should terminate. So you should have that base case, and then rest of the things will become intuitive. Let's write the code for this factorial, and rest of the things will become very clear to you guys. Okay. Now, so if this problem is given to you, what is the base case here? What will be my base case here?
If n is equal to 0, it will terminate and
So-
come out of the loop.
So the base case should be the most granular form which you can think of in this problem. When I say n factorial, I can write this as n minus 1 factorial multiplied by n. So assuming that n is a big number, or maybe anything, 125 equals to 124 factorial multiplied by 125, something like this. But the most granular form of this will be 1 factorial, right? The most granular form will be 1 factorial, because 1 factorial is what? 1 factorial multiplied by 0 factorial. 0 factorial is also 1. 1 factorial is also 1. So these are my two base cases you can think of. If I have n equals to 1, then I should return 1. If n equals to 0, I should return 1. Give it a minute, think a little bit, and let me know if you have any questions. Let me just clear the screen a bit, and then let's write the solution for that problem, and then let's understand the concept. So I can write something like this. So this is like direct solution from the assignment problems. Okay. So one I am going to solve, one will be as an assignment for you guys. Okay, but try to implement both of them, although like I'm giving the solution here, but try to write code yourself as well. So def, let's say I'm giving the name as factorial, and it will take one parameter, and then I will say I need to have a base case. So let's say I'm giving the base case as we will modify the code as needed. We will run through, like we will do a dry run of this code. We will see like if there are any issues, and then we will fix it. So if n is less than 2, okay, that was my base case, right? If n was less than 2, because till 2 it is fine. The most granular was 1 factorial, because after that it's always going to be 1, or maybe not defined. So the most granular form will be factorial of 1, correct? So if n is less than 2, return 1. That is something fixed I'm returning here. The most granular form, it cannot break further. You may not be able to break it further. Else, return n multiplied by factorial of n minus 1. So see this. Can you see this? What's happening here? I'm saying factorial. So this is the function. So inside the function, I am calling the same function. All this while, what you have done, what you have seen, this is, let's say, my function 1. In function 1, I am calling function x, which is not equals to 1. So I'm calling some different function. But in this, in factorial function, I am calling the factorial function itself. So this is called as recursion. It will go in recursion. It will do that thing in, you can think of as a, it is a recursive process. Recursive is also an English word, like it's recursive process. Okay. Now what happens, like when you give 5 here, so when you are trying to calculate factorial of 5, it will check n is less than 2. No, right? N is not less than 2. It will go in else block, and then it will return n, that is 5, multiplied by factorial of n minus 1, that is factorial of 4. Now from here, from this line, this was my first. Now from factorial 4, it will again call this function and check this. Is it less than 2? No. Else, again, it will break down this into 4 multiplied by factorial of 3. And then this will be broken down further as 3 into factorial of 2. Then further it will be broken down to 2 into factorial of 1. Now factorial of 1 is what?
1.
Now factorial of 1, it will again, is it less than 2? Yes, less than 2. So return 1. So now it will return for this 1. And after this, your program will terminate, and then it is going to calculate everything for you. Okay. So this is how it works. No complex for loop, nothing. You just need to have this structure and it will do the thing for you. Internally, it's like it is calling some assistant for you, and it is dividing the task, and it is giving it for solving such kind of problem. But now let's do this. Will this work for every cases? Now once you have done that, you validate it. Factorial of 1 is 1, right? Run through this code. So factorial of 1 is like, it will check if in, yes. Please keep yourself on mute, Justin. Yeah. So factorial of 1 is 1, right? So this will work fine, because if n less than 2, return 1, else everything is fine. Factorial of 0 is
1.
1. So for that also this will work fine. So this is a simple recursion problem example. Same you will need to apply for Fibonacci. Now in Fibonacci,
Sir, that Fibonacci problem,
uh-huh.
that if you are giving limited short number of the term will be 10 to 20, then we are getting the output. If you are giving more number, then it is taking time.
Yes, it will take time. That is what I'm saying. Recursion is not efficient. It will take time. So for that, you will need to apply a little bit of dynamic programming. But that's fine. If you do not apply dynamic programming or anything, I'm completely okay with that. Just like for 10 to 12 only, if you can, if your Fibonacci number works, that should be good enough for now. Okay. Okay.
Sir, I have one doubt. In factorial, we may not need global variable, but Fibonacci we should use or we should not use?
Not required. Not required. Not required. Just through recursion, you will be able to do it.
Okay.
Okay. So in Fibonacci, what is so this is the pattern. Your first number is 1, second number is also 1, your third number will be 1 plus 1, that is 2, then 2 plus 1, that is 3, then 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 30, and so on.
But in that case, we will be entering the number, right? Suppose I entered
You will be entering the number, and
entering number.
I just want to print the nth Fibonacci number, that's all.
That means if I'll enter 3, then I should get Fibonacci series of third position. That means 3 means it will be 1, 1, 2 or
So
1, 1, 2, 3.
if you give 3, then it will just print 2 for you, nothing else.
So 1, 1 anyhow it is constant. Without 1, 1 we cannot form Fibonacci series.
So that is what I'm saying now. Like if you give n equals to 3, it will print 2 for you. It is not going to print the entire series. It will print the nth element in that series.
So I agreed, but nth position will it be 3 or 2 if I enter 3?
What is the nth position? This is my first position, this is my second, and this is my third position.
Okay.
No,
I mean, if you'll be including 3, then it should go up to 3, I thought.
No. Third position, nth Fibonacci, third number in the series. That's all.
Okay. So
Okay.
n minus 1, and then you have to add n minus 2, not with
No,
n.
let's not discuss the solution, Lily. That is for the assignment. Okay. You try that out. Okay. I mean, nth series number, like when I say 3, third number here, 1, 2, 3. That's it. Okay. And similar concept, like the way we are doing for factorial, try to implement see this Fibonacci numbers also you will be able to solve in different ways, but there are different ways of solving this, making
I
it more
did it
efficient.
with a global variable. That's why I asked whether local will also work out. I think it will work out.
I would like to see your solution, Lily. Just share it with me. I mean, the global variable as such is not required, is what I think.
You
I
just
mean,
now you want to see because my laptop is not working. I mean the
you
net
can share
in.
you can share it with me over
I'll
mail.
share with you in WhatsApp personally.
Sure. Okay. And for again coming back, like for this Fibonacci problem, what you need to do is similar to what factorial, because I want you guys to practice this recursion style. Okay, and for this Fibonacci also use similar style of coding. Okay, there are very interesting problems related to recursion. Again, like there are problems there are very standard problems if you search online, and you will be able to do it. But these are two of the problems like which forms the base. Just practice this well, understand every line of it, and you should be able to do it. Okay, so both factorial and Fibonacci, solve it for the assignment problems. What else we had in assignment? Yeah, Fibonacci and factorial, right? So this is the one, and here I already gave you one hint. The normal way of doing it is just iterating through nested loop, and then if it is found, then print found, as not found. There can be a better approach to handle this, and that is using exceptions. So if you are able to do it, if you are able to try it, good. So again, like exceptions, as I mentioned, whenever you want to raise an exception at some event, for now you can use raise value error or divide by 0. Let's keep it simple for now. Use anything, either value error or divide by 0. Any questions?